Hi. So for part B, we've been told the force of magnitude 4 newtons is removed. Find the acceleration of P down the plane. Okay, so again, the first thing I'd recommend to do is draw a nice big diagram, obviously without that 4 Newton force that was there before, okay, because it's been removed. So we know there's nothing holding the particle up the plane anymore, so it is going to fall down and it's going to accelerate down towards the bottom of the slope, okay? So I'm going to start to draw in all of my different forces now. Okay, so the particle has a weight and its mass is 0.5 kilograms, so its weight is therefore going to be 0.5 g newtons, acting vertically downwards. So what I'm going to do now is I'm going to start to resolve the weight and find the components perpendicular and parallel to the slope, okay? So if I look for this force here, I know that this angle is alpha, and that can be proved. So this force that includes the angle is cos, so this force is 0.5 g cos alpha newtons, and I know the force that does not include the angle is sine, so the component of the weight which acts down the slope is 0.5 g sine alpha newtons, okay? And again, the particle is not falling into the slope, so there must be a force which is keeping it on the slope in this plane, so that's the normal reaction, okay, of magnitude r newtons acting perpendicular to the slope, okay? So I know the particle is accelerating down the slope, and it's a rough slope, so friction is involved, and friction always opposes motion, so it's going to be acting back up the slope there. Okay, so we have that frictional force of magnitude F newtons acting up the slope. Okay, so that's all my forces in my free body diagram. So what I can do now is I can start to resolve. Okay, so I'm firstly going to resolve perpendicular to the slope, keeping this direction as positive. Okay, so R is positive, minus 0.5 g cos alpha is equal to 0. Okay, so just applying Newton's second law of motion, sum of forces is equal to mass times acceleration, and the particle is not accelerating in this plane. Okay, it's accelerating in this plane, and we'll deal with that after, but in this plane it is not accelerating. So the acceleration is 0, hence all the forces added together is equal to 0. Okay, the sum of all forces is equal to 0. Okay, so if I rearrange for r by adding 0.5 g cos alpha on both sides, we get r equals 0.5 g cos alpha. Okay, and I'm going to call this equation 1. Okay, so the next thing I'm going to start to do now is resolve down the plane. And I just want to point out here, it's probably best in this situation to resolve down the plane because our acceleration is going down the plane, okay? So if we were to resolve up the plane, our acceleration would come out as negative, and we would then need to change that in our answer and say the actual acceleration down the plane is a positive value of acceleration, okay? So resolving down the plane, we get 0.5 g sine alpha minus F is equal to mass times acceleration. Now the mass is 0.5 and the acceleration we don't know is simply a. Okay? So now on my next line I'm going to divide both sides by 0.5 because we're looking for a. So we get 0.5 g sine alpha minus that frictional force divided by 0.5 is equal to a. Okay? So I know queuing layer 1, I know, just like in part A, that F is equal to mu r, Okay, so frictional force is equal to the coefficient of friction times by the reaction force. So I can replace F with mu r in my equation. Okay. So on the next line, I'm going to substitute my value of sine alpha in, and I'm also going to substitute equation 1 into our equation 2. Okay. Well, this is equation 2. Okay, so 0.5 g. Now I know that sine alpha is 3 over 5. Minus, okay, so mu from our previous question is 0.207 to 3 decimal places. What I'd recommend you to do is use your answer button in your calculator, pressing shift and answer so that you do not lose any accuracy. Times by the reaction, which is 0.5 g cos alpha. And I know that cos alpha is 4 over 5. Okay, so I'm just going to substitute that in as well. Divided by 0.5 is equal to A. Okay, so we should get a value of A being 3.76 meters per second, and that is acting down the slope. Okay, so positive sense, and we've taken this direction to be positive. So the acceleration is 3.76 to 2 decimal places, acting down the slope. Okay, so thank you very much, and I hope you followed.